We have defined wide sense stationary random processes. A random process which the mean of x of t is constant, and Rx of t1 and t2 is only a function of is a function of time difference. Only a function of time difference. Now, if we have more than one random process, we want to extend this definition. For one random process, the wide sense stationarity is defined based only on mean and autocorrelation or autocovariance function. For two random processes, the joint wide sense stationary processes, the definition is straightforward. We say that two random processes, x and t and y of t, are jointly WSS or wide sense stationary if they are individually wide sense stationary, and also their cross correlation function is only a function of time difference, or if this function also is invariant if you apply same delay to both t1 and t2. So this one shall be equal to Rxy of t1 plus a time delay, let's say c, and t2 plus c for all t1, t2, and c. So in that case, two random processes are jointly WSS or JWSS abbreviation. So if only this depends on the time difference, we say that, and also so in other words, the mean of them individually is constant, is not changing in time. The autocovariance of each of them is constant with the time delay, or is only a function of the time difference. And the cross correlation is also only a function of the time difference. So in that case, we can also use this abbreviation, and also this is equal to mean of x of t plus 2 over 2 divided by y conjugate of t minus 2 over 2. We always put a conjugate on the second one in case that they are complex random processes. If they are real, you don't need to put them, but it won't harm you to put the conjugate. So obviously, you could write this one for cross covariance. So if these guys are a function of time. So these are abbreviated notation. If we know that they are JWSS, if we don't know they are JWSS, we cannot use this notation. We need to put another time variable, because this will become also a function of time and so on.